Today, I am doing project one. Oh, actually, project three for this. I don't know why it says project one for the 2D wind tunnel simulation. Um, with all these different types of assumptions and things. And example, the height needs to be this, the length needs to be this. Yeah, yeah, yeah. Um, but for the test section, there's a specific formula we're gonna use, which is this. And then to find the inlet velocity, you have to times it by uh, this over this because you have to use the formula A1 V1 over V2 A2. And yeah, so let's just get right into it. We'll talk about that later. So to begin, first you need to open up your ANSYS. You go to fluid flow fluid right here and then drag it to over here. And to get the thing on the side, you need to go to view and properties. Now let's go to geometry. And the reason why we had to do that was because you need to switch from 3D to 2D, like what we always do. Right click, open up new design model or geometry. First things first, click on the Z, then go to XY plane, and go into our sketch right here. There are many ways to model this, but here are the constraints I'll be using. Like I said in the beginning of the video, which is basically right here. And for me, I'm doing the second person, student two, which is the frequency of 40. Yeah, let's get back into the project. First thing, draw a line from x equals 0 in the origin. And draw another line from here to here. Go to constraints. This line has a midpoint. Basically put the midpoint in the origin. That's what I did. Basically by doing this and clicking onto here. Now we need to dimension the settling chamber intake, which is what you need to do here, there. This is 22 inches. So, well, this is in meters right now, so you need to convert it to inches. To do that, you need to go to units and convert up here to inches. Now that it's in inches, set it to 22 inches. Now you can zoom in on it. And now we need to start drawing our model, which we can do with just lines. Let's start with our settling chamber. And I believe it has a dimension of 15, which we'll put later. And then we'll do our contraction chamber. Let's just go do that. So first you need to draw a straight line horizontally like this. And then you need to draw like a contraction chamber. So you need to like go like this. And then we need to add the test section. And then our diffuser right here. Something like this. It doesn't need to be perfectly like mine because we will be using dimensions to change it. Okay, let's go to dimensions now and go horizontal. Now we need to do this one first. Go horizontal, get the corner. This is our settling chamber length. So this will be 15 inches. We know our contraction chamber is 24 inches, so just go to the, you switch to length to distance, and that's how you get the curve right here. And this will be this contraction chamber length. This is 24 inches, so it's this one here. Now you go back to horizontal, and this length here will be 12 inches, H6. Go back to length and distance. And this length over here is going to be 42 inches, just like that. It does give us angles in the assignments. Says the angle of our half diffuser angle is 3 degrees. So that is the angle between this and this. So the angle, 3 degree angle is like this degree right here, if you can see. So to do that, we just click on this and this. And I believe this will be 177 from this to this, so then it can go up. No, 183 actually, because it's supposed to be pointing down like that. So also the height is from here to here is going to be 3 inches. We see that in the dock here. It is the 6 inches, so just 6 divided by 2. Since we are building only half of the thing right now. E9, this should be 3. Now we have one side of our diffuser mostly complete. Now we have to do the top section. What we can do is modify, and then we can basically like mirror it over. Basically, we need to first select all these lines right here using control, and then go into replicate. We're gonna do a 180 degree and 2 for F. I'm gonna indicate right here. There's our thing. What we're gonna do is right click and then flip vertically like this, and then put it on our edge over here. And then you could just put it on the endpoint right here for it to have a great graph. Now, since we moved it there using the replicate command, now since the dimensions didn't carry over, we need to redo those dimensions. Basically, we already have these dimensions here. We just need to redo it. To do that, you need to go to dimensions. This is going to be pretty easy since we've never been through this. This is go to dimensions, horizontal. This is H11, which is equal to H2, which should be 15. That is right. L5, 24. That is right. L7, this is equal to L7, L13, L7 are right, 22. And this horizontal should be H6. We're just double checking here. H14 is equal to H6, that's good. Now we have to double check our height and angle, just doing vertical. P15, oh see, this is wrong. This needs to be 3 inches instead of 2.9. There we go. And also, we also need to do the angle, check it. This should be 177 because it's at the bottom. I mean, at the top. 177, this is 183. Okay. Because this is 360 minus 177, which is 183, which is 6 degrees. Okay, we're good. We need everything to be blue, so wait, what dimensions are we missing? Where thing is still underdefined. So what I did was added this length. Okay, I'm back. I finally figured out how to get my thing fully defined. Basically, what you need to do is to add a line right here and to add a vertical dimension here. So then these 2 points, then this line will be defined. What I had trouble was this line and this line being underdefined. So that like adding this line in this dimension right here solved the whole issue. Since now everything is dark blue instead of this light blue, it is fully defined. Next thing we need concept, surfaces from sketch. Click on sketch one now, everything's selected, and then hit apply. Then hit generate. What? Okay, a little backtrack here. I had to redo my sketch because it wasn't a closed surface, and the surface didn't generate. The reason was because this point and this point weren't coincident. That means they weren't touching together, so there was a little space to make there's a little gap in between. So that's why I had to redo the whole thing, and that's why you see these big numbers here. So basically, the problem I did was that I didn't go to constraints and go to coincidence right here and click on the 2 points and those 2 points weren't touching. So that's basically what you have to do. And then so now as you can see, we have a lot less dimensions that we had to do because those two connected, weren't connected. But now they are. The next thing we want to do is after we get a fully defined closed dimension system, is that making sure we are in inches and degrees. There we go. Um, to concept, surfaces for sketches, and click on sketch 2, and then click apply. Now it should change into a whole light blue, and you should generate, and then you will get a surface like this. Now the next thing we have to do is mesh this thing. To do this, first we need to save this. So go to File and click Save, and just put it in wherever your ancestors have done all your projects. Now after we saved it, Control S to make sure we go into our meshing tool. Now that we have our mesh open, go over here, insert method, hit on this for the geometry. For the selection, apply. Method should be triangle. There we go. It should be one body now, triangle. Use global setting. Now we go over to generate. We can right click on our mesh and now we can see our mesh of triangles. However, we are going to change the default element size to 0.1 for more accurate. 0.01. Hit generate. And there is our cool mesh of triangle. Now that we have our mesh, now go to this tool here, select curved edges, select all of them, hold control, just like this, and call this wind tunnel wall, and then select on this edge, and call this wind tunnel outlet, and then go over here, and just wind. And now we can go over here and mesh, name sections, and we can see all of our different names we added. Mix up, make sure it's saved, Control S, and then close it out. So here, update. Now there's a check mark, which is good. Click over here in the setup. Once it loads, hit double precision, solver processes 2, and hit start. So it is an absolute planar, steady, and pressure for the base. We need to go into models, and then energy off. Turn out energy equation on. Now it says on. Now go over to viscous. Go to K epsilon. Oh, go to K epsilon, and then enhanced wall treatment, pressure gradient, and thermal effects on. Hit OK on that. Next thing, we need to go to our boundary conditions, which are right here. This is where we're going to set our wind tunnel inlet velocity here. To get velocity inlet, you first need to find, to get the velocity inlet, the thing you need to do is to first plug in your frequency into this formula to get the velocity of the test section. And then after you get the velocity of the test section, you put this into A1, B1, which will give me 2.6139 meters per second for inlet after you plug in A1, B1. It's just via test section times 6 divided by 22 right here. And then, so for me, your cases might be different, but for me, I am doing 2 points, my velocity magnitude 2.639. And now we just hit apply. Next step, you need to go to initialization, initialize it, and run the calculations. Number of iterations, let's just go 150. It doesn't matter really. Calculate this. Now our graph is being made for 150 iterations. Calculation is complete. We can see our graph right here. Okay, what do we need to do? We do the velocity, static pressure, total dynamic pressure, contours of the wind tunnel, and then we need to get the velocity, static pressure, total pressure, and dynamic pressure along the center line. So to do that, what you need to do is go into contours, go into graphics, contours. We're going to select all of these here. Static pressure, save display. We have dynamic pressure, save display. Screenshot this. We have total pressure, save display. Now our velocity magnitude, save display. You can see the velocity on the walls here is 0, and there's a lot of velocity in the middle here. Screenshot this. Here's all of our contours. That's 1, 2, 3, 4. Yes, we do. Now we need to plot our graphs. We'll set up this. Go to XY plot. We're going to go to new surface, line slash rake. We need to find the center line. So what we need to do is go back to our geometry right here. Then we can go to, we just need to, we did put a center line here. We just need to find x0 here and x2. Change the units over here to meters. Come down to tools, go to ANSYS tools, analysis tools, and distance finder. And we need to go up here and change this to click the edges. Click the first edge, click the second, apply. Just click one of the edges for this one. Apply, and then click the end edge over here. And this should give us the distance, 2.3259 meters. Now that we know our distance, we come back over here, close out of it. Remember at 2.359, go from x0 to 2.3259, because that's our distance from here to here. This is the center line. Since it's at y equals 0, like this line right here is y equals 0, so we don't have to change this. Create. Now we have a center line right here. Static pressure, save plot. Here is our graph. I just screenshot it, but I'm just doing this just in case. Write to file for Excel. Now we need to do dynamic pressure too. Let's just turn this off so you can see the plot. Here's our dynamic pressure graph. And then write it to file. We have total pressure. So with the plot, here's our total pressure. Write the file. And our velocity is the last one. Something like this. Thank you for watching. Again, that is uh, for 40 hertz um, for this project three. We did get everything dynamic total static velocity for the plot and the contours. We should be good to go. Thanks for watching.